Hey everybody, I'm going to be up and running in just a second here, visually, and I should be right here. Hello and welcome everybody, welcome to SkyTour live stream. It is your humble host, Mark Antonio. Nice to see you guys here. I'm just getting a few other things straightened out here. Let's try this. This should work. So how is everybody tonight? There we are. I am doing great myself. Nice to see a bunch of people showing up already. This is so cool of you to be here. I want to welcome Tim McGlynn. Hi there, Tim. How are you? Nice to see you. I haven't seen you before. Maybe you're a new face to SkyTour. That's cool. Go ahead and subscribe. That'd be fun. And I want to say hello to the first one that was here, and well, besides me, and that was Timothy McGlynn. So he was the first one here, so he gets an extra shout out. Wayne Pinkham's here. Wayne's a good friend. I've known him for a long time. Hi, Wayne. Nice to see you. And we are in the process of getting things lined up over here. This is our view tonight into the heavens. For those that are just joining us and haven't seen what we do, I'll just give you just a brief overview because it's kind of cool. Show you what we do. And to be fair, let me just run through that with you first. I think that's a good idea. Okay, so over here, this right here, this is our camera view in the red box there. This is our computer view. Telescope in the building is right here. I don't know who this guy is. He's just always in here, you know. And over here is our main view, naturally. You can see that bouncing around. We have some wind out there right now. And this is the parameters for the cameras. Okay, we have a focusing section here. We have an extra processing node right here. And the most important features on this entire image and this entire screen is the exposure right here. Okay, and the gain right here. These two are the two that matter the most. The gain is the sensitivity of our sensor, and the exposure is how long we're exposing that sensor. Very, very important. So I wanted to thank and congratulate our last winners. That was Richard McFarland, who I haven't seen out here. Richard, if you're here, let us know. You won a pair of binoculars. And Karen Belmont, who is in the chat. And I want to know if she got her binoculars. They were supposed to arrive today. So I'm hoping she got them. Anyway, let me know when you can, and I will be happy to announce it. You're wondering where Daryl is. Daryl's got a computer issue. His computer is, failing him. So I asked him if he wanted to join tonight, and he's like, oh, well, you know, the computer's running slow as mud, he says, but I'm sure he'll be in the chat. Okay. And we also have, let's see, who else do we have with us tonight? We have C&D Boy. We have Rockstar. Hey, Rock. Renee is with us. Hi, Renee. Renee's got all these cool emojis she sends out. It's really neat. And then we have Daisy and Zoe Amethyst. Hi, guys. Nice to see you. And let's see. I just saw, Renee Cruz says, I just saw like on KG, right? What's that mean? Oh, Rockstar. Okay. All right. To Rockstar. Sorry. All right. So we have Tiffany is with us. Tiffany Echo and Richard Spencer. Tiffany is one of the two people that gives us equipment to give away. And we just love talking to her, and she's a good friend. Okay. So now Karen's mentioning chocolate. I asked you if you got your binoculars today because they were supposed to arrive today. So I'm waiting to hear from her on that. All right, so we are currently doing a last gasp of summer last gasp of summer tonight. So we're going to be looking at a few objects in the summer sky. This is one of them. You can't tell right now because we're viewing it like you might see it in the telescope. All right, and we're in our low light mode, but I'll show you what it really is. Yeah, you want my sound up, I can tell. Let me see if I can turn the sound up a little. Is this a little better? No, wait. Maybe this way? Yeah, okay. That's a little too much. That's too hot. So maybe like this. Maybe like this. Okay. So my sound is up now a little better. And I can turn down this. Thank you for letting me know, C&D boy. I had a whole bunch of radio shows I had to go on, and they kept saying, "Oh, your sound, you're too hot, you're too cold. You gotta." So I had to keep changing my equalizer and get all my sound up, And so I did. And when I did it, well, as you can imagine, it wasn't reset to what it should have been tonight. Okay. And Timothy McGlynn says, I live 2 blocks away from the Harrisburg, Pennsylvania State Museum, and I go to the planetarium show. Haven't been there in a while. Well, guess what? You're going to see one here, man. We're going to take you around the remains of the summer sky tonight and some of the winter stuff that'll be coming up. And Renee Cruz said, I just saw Mark D'Antonio on Podcast UFO, Martin Willis Street. Yeah, that's right. I was just on there. And Karen Belmont got her binoculars today. Tiffany Echo, who sent them to her. I want to thank you publicly, Tiffany. You guys do a tremendous service to people getting started in a hobby. And I'm really happy that you got them, Karen. Make sure you use them. If you don't use them, well, we're going to come over and take them from you. No, we won't. I'm just saying that. All right, let me make an adjustment to the lighting here. And this should do it right there. There we go. I had to adjust my lighting a little bit. There we are. All right. I got SkyTourLive.org. It's in my way. I got a haircut today, so I thought maybe the lower hair wouldn't get in the way of the logo, but I guess it still does. All right. There we go. Just lower that a little. Oh, you know what? I can raise this now because I removed the second security camera in the building. Well, I say I removed it. I had no choice. It crapped out. Sometimes it works, sometimes it doesn't. But the telescope is the most important thing, which you see right up there. Okay, so I can actually move up here now. So there's the telescope up in the building right there. And that telescope is 2,600 miles away from me. I'm in Connecticut. I'm running the telescope. And so I gave you a tour of this stuff. Let me show you the last screen. This is our planetarium that's built in. And I want to move our telescope right down here. So I'm going to have it go to that spot in the sky. So I just told it to move to that spot in the sky. So you'll see the stars shift here and go up in just a sec. There they go. All right. And you'll see the SkyTour reticle show up in the middle of this spot here in just a minute. And that is the location of our telescope. And there we go. Right there. So now if I come in here and I take a picture, we should see if I'm probably going to actually just lower this down just a tiny bit. I mean, just a tiny, tiny bit. This is an area called the Cygnus wall. And I want to show you the Cygnus wall. Let me see if this is set on. Oh, max. I don't want that. Okay. I want that to be on a level of 4, my speed in there. No wonder it was going too fast. Okay. So we're going to come back here. All right. And we're going to come back to this spot right here. Right there. Okay. Let's go there right now. Tell it to go back there. I had the telescope on a slew, a big slew, so it was actually way too much. It was moving too quickly. So now it'll be back here in a sec. All right. So now we come back in here. And this is the Cygnus wall right here. You can't really see it, but you'll see it in a second. And there goes a Starlink satellite. Wing, right through. Yep. All right. Okay. So let's take a picture now. We're gonna come over here and we're gonna set our exposure time to 25 seconds. So the telescope camera will be exposed for 25 seconds. We give the value in terms of milliseconds, so it's 25,000 milliseconds. Or we can say 25 and then an S if we want to. All right, so that's 25,000 milliseconds, and we hit the key, and off it goes. You can tell by this that this is our progress bar down here in the lower right corner. We're going to come out of low light mode and go into deep space mode, deep sky mode, right here. And let's do that. And go into our live stack. Noticing also, because we use Starlink, that the Starlink satellites are just a little bit. Oh, this is too slow. I don't know why it did that. I got to set the exposure again. There we go. And then this, and that should be the one. Yeah. Okay. So there's our progress bar now going along the bottom, and we are building now. This screen is a stack. It's going to take an image, take a second image, align it with the first, stack it on top, and build an image sandwich. The more sandwich, the thicker your sandwich, the more meat that's on the sandwich, the less noisy digitally, and the more clear the image will appear. So when this first one comes in, you'll see that it's really pretty. But to see how really pretty it is, let's first of all color correct it. Then let's get in here and play with the curves a little bit. All right, and we gotta come in here and do this, do a little processing, boom. And now we have our Cygnus wall. It's an area. Okay, first of all, what is the Cygnus wall? Where is the Cygnus wall? If we look in our planetarium, okay, we back out. This is the constellation of Cygnus the Swan that you're seeing right here. Okay, this is the swan, and when we look here, this is the head of the swan, the middle of the body, and the wings, and the tail. And in mythology, this is what we're looking at right here. That's the actual swan. All right. What we're also looking at in here is we're looking at all these cool things, and where our crosshairs are is the area that we're actually focusing on. And so right now, we're in this feature called the North American Nebula, and the North American Nebula has this strange feature. First of all, what is a nebula? A nebula is a cloud of gas. Okay, like this. You can see this red stuff. This is hydrogen gas, right? And let me actually enhance it a little bit for you. Okay, let's bring this curve in. Now you can see, look at that. This is live, guys. This is live in real time. And this dark stuff is dust that's in between us and the nebula behind it. Okay, so this is ionized hydrogen gas. Hydrogen is the most abundant element in the entire universe. So it stands to reason that there's going to be a lot of it floating through space. And so what we're looking at here is just this. This particular nebula is full of this hydrogen, and there's hot stars that are buried inside this dark cloud that are actually exciting this hydrogen to glow. Further, the star Deneb, which is nearby, if we go back to our planetarium, Deneb is a bright hot star that's right here. It's right there. And Deneb is a giant star. If you look at its spectral type, we can see that it's a, let's go back, okay, it's an A21A. Now, the spectral classes go O, B, A, F, G, K, M. And then the 1A is a luminosity class. So we specify stars with two things, a letter and a Roman numeral. And the letter tells you the color and the temperature, and the Roman numeral tells you basically how big it is, where it is in its stage of evolution. Deneb is near the end of its life. It's a 1A. It's a supergiant star, and it will go supernova. And when it does, it's going to litter its contents to the cosmos, which is what you're seeing here. This is all stuff. All this is stuff littering the cosmos. These gas and dust is littering the cosmos from previous supernovae that have occurred, and billions upon billions upon billions of supernovae. And the reason there have been that many is because there were many stars forming, number one. Number two, those many stars that were forming were so big and massive that they only lived a few million years, not billions of years like our sun. Our sun's going to live 10 billion years, and it's 5 billion years the way through. So But 10 billion years is a long, long time on the scale of the universe, because the universe is only 13.8 billion years old. You like all that? So it's crazy, I know. So this stuff is the detritus, the litter of previously destroyed stars. But man, look at it. It's just crazy, isn't it? It's really, really beautiful. Now, in the past, we would have taken, as astronomers, I am a professional astronomer, that's what I went to school for, we would have taken images like this in black and white, right? But with the advent of these new fast and wonderful cameras, we can take full color views and show them to you. And our telescope you're seeing right here above me, that's 2,600 miles from me, that telescope we put in runs 25 times faster than the normal scope of its kind. And we've modified it, thanks to Starizona in Tucson, Arizona, to have a hyperstar system on it to actually allow us to increase the speed of our telescope dramatically. And that means that when it comes to what I do as an astronomer, which is to do public outreach and share the universe with everyone, that the sky comes in much, much faster. This is a 25-second shot, and we're getting this beautiful dark nebula and stuff in the sky. This is usually stuff that's reserved for much longer, deeper exposures of many hours. But we can do it in a few seconds. So that said, we also have a very dark sky sight. The last piece of our puzzle that I'll show you is this one. Okay, this is our all-sky cam. It's the one I built the all-sky cam to showcase what's going on. This bright thing down here, this is actually the moon. Okay, but we can see if we click this button, we can see the constellation overlay. There's Deneb and Cygnus the Swan right here. Okay, Vega is the next star there, and we have Altair down here. So we have Deneb, Vega, and Altair. These are the summer triangle. And earlier, they were right here. And I say earlier, that is earlier in the summer. But now, when the sun sets, they're right about here, and they will be setting and going away, leaving us this new stuff coming in. And what's coming up over here on the horizon? Orion the Hunter and the winter sky with an even more glorious, beautiful Milky Way, the winter Milky Way. Because the regular Milky Way goes like this and comes across and down here. Why is it curved like this? Because it doesn't look like that in the sky. Well, this is a wide-angle view, and it actually makes the sky look, I would say, distorted, because it's like a fisheye lens. All right, so that's what we're looking at right here. And if I get rid of this, you can actually see the Milky Way right here, even the colors in the Milky Way. Beautiful, yes. All right. So, Hein Cherry, how are you? Nice to see you. Sam S. is with us. Cosmo Edits, how you doing, man? Mike Galea, good to see you too. I am so happy you guys joined us. Now, anyone that has not subscribed, go ahead and do it. It's free. You know, Mike M. is with us. Hey, Mike. So, he says, so Tucson is great for night skies? How about Yuma? Yuma's better than Tucson, okay? Tucson is a city, and they've got some bright lights. Even though Arizona's a dark sky state, it doesn't seem to matter in the cities. But when you get away, look at this. So when you get away from it, it's really beautiful. This location where we are, let me just bring up our all-sky cam for you again. Okay, this glow here, this is Phoenix, which is 75 miles away from us here. But that's the glow we see. Right, the Milky Way is horizon to horizon. Not only that, okay, this is the glow of the setting moon, by the way. The Milky Way goes horizon to horizon, and the nice thing about it is that I have a photograph which shows the Milky Way going down to the horizon right after sunset. So you see the orange sky of sunset with the Milky Way coming down into it. That's how dark it is. Richard McFarland, guess what? You want a pair of binoculars, brother. I'm glad you're here. You have to go here. Go to skytourlive.org, my friend, and tell us the information we need to send you these binoculars. That stuff, that only goes to me, and I'll share it with Tiffany, who's also here. That's why she's saying, Richard, we have a pair of binoculars for you. You won last time. And in case you didn't know that, guys, thanks to Tiffany and Michael. They're basically a power couple with SkyTour Livestream. We give away equipment courtesy of them. And so we're happy Happy to see you too. And of course, Marianne is 1/3 of the SkyTour live stream nonprofit company that we have. And she is celebrating a birthday today. So make sure, I don't know if she's in here, but we need to wish her a happy birthday. Now, here's the thing. We're trying to we have another telescope that we want to put in another observatory 200 miles away from this one. This one's out west of Phoenix. We're going to put one east of Tucson, out in the desert out there on a mountain now, and we're going to be sharing that mountain with other astronomers, professional astronomers. And we really got a good sweetheart deal because we're a nonprofit organization, but we do need some financial help. I'm hoping that maybe some of you can go to skytourlive.org, click the donate button, and give us anything you can that might help us, because we want to be able to, we got to buy the pier. We have to have the monthly fee for the building. And then we have other in sundries. We've got to have installation of the telescope done. And it's really, really, really as rock bottom cheap as we could get it. But it's still expensive for us because we just don't have the money. Now, the other thing is we discovered that Apple is now charging 30% of everything we make on our Patreon if you use an iPhone to connect to the Patreon and join our Patreon that way. And that really stinks, because now all of a sudden 30% of everyone who's contributing are throwing their money away unless they can change over to doing it without using an iPhone. If you're on Android, fine. If you're watching it on Android, no problem. If you're watching it on the computer, no problem. But if you pay the Patreon using Apple services, then 30% of your money is going to get given to them for no good reason whatsoever. So maybe you might want to consider just going back on the PC and doing it from there, and then forget about it if you want to. That's if you join our Patreon. If you want to donate at skytourlive.org, just don't do it using Apple services, and you'll be fine. You know, we'd love it. We could use the help. We need the financial support. And, you know, I don't get paid. I'm not getting anything. I'm not looking for it. So I think I'm very, very happy that we're all together on this and that we can do what we're doing. Excuse me. Okay, so we have 26 exposures here. If you notice, they are really pretty. And you can see the details showing up in here. Let me show it even better. Ready? I'm going to click a button and you're going to watch it get even better. Oh, look at that. That came in really nice. It changed nicely. And let's actually add another slight detail enhancer. Oh yeah, now you can see all the details in this cloud. Look at that. Let's zoom in. Look at this stuff. Now this is light years long. And if our solar system was inside this cloud, we would probably never know it, because we wouldn't see where we are. We wouldn't know that we're in it. Wouldn't know we're in a cloud. Like if we're in this dust, we wouldn't know we're in this dust. And interesting thing about the dust is that we might actually be in a dust cloud like this, okay, that we're seeing right here. And that reason is because the Pleiades is about 400 miles, the seven system, 400 light years rather, away from us. And so with the Pleiades being 400 light years away, we know that they have dust around them. Well, it turns out that the dust we're seeing, that the Pleiades are reflecting their light off of them, okay, the dust might actually extend all the way to our solar system. So just like this dust cloud can be light years long, this is dust, not a void, okay, in stars or in the dust or the gas. This is dark dust laying over, and you can see it very clearly when we zoom in over here. You can see very clearly that this is an overlaying dust over bright nebula behind it. And we might be in something like this, and if we are, it means that we're not we're not able to fully see the universe for what it is because we're looking out through dust. So it's one of the latest ideas. This is the entire frame of our view. And this frame right here shows 1.5 degrees by 1 degree in height. So that's 1.5 degrees. This is 3 full moons in diameter. And it's 2 full moons in diameter tall. So it's a wider field, you know. So this is neat. And we're up to 32 frames. I'm going to show you another feature we have. We actually have an identifier, which is called an annotator, and now you'll see that the stars are labeled as such, and so we know what's in the field. And I'll save it with the annotations so that you'll get this exact image saved. Okay, and that's cool. And then I will mark this as what's called the Cygnus wall, and Cygnus is Cygnus wall. The wall is the feature known as this dark dust here. Okay, so now when we save this, you'll see this green line that says we saved it as an astronomical FITS file, FITS format. But you can't use that, so we'll also save it exactly as seen. And so here's the exact image that's going out on our server tonight, right there. You can take this image for free. Download it, check it out, enjoy it. Okay, and you can find all the images here at SkyTourLive.org. Scroll down, and you will find a entry that says "Take me to cool images," and there's some instructions on how to get to them. So enjoy. And if you have any questions for me, you can go to SkyTourLive.org, and you can hit the email button in the upper right corner or contact, and I will get the message. Actually, Marianne will get the message. Tara will get the message, and I will get the message. Tara, Marianne, and I are the 3 people that started SkyTour Livestream as a service to help educate people around the world in the sciences. And I'm having a lot of fun with it, as you can tell. I'm also just a head. I'm a floating head, the big giant head. If you remember the movie or the show, Third Rock from the Sun. Okay. So, this is 36, and we'll save it here one more time. And if anyone has any questions about the Cygnus wall, put them in the chat. Okay. Yes, you won the binoculars, Richard. He says, oh my God, did I win the binoculars? Yes, you did. You did. You and Karen, who appears alongside you right above you, are the winners from last time. So go here, Richard, SkyTourLive.org, upper right corner, look for email or contact, send me your information, I will get it to Tiffany, and bam, you'll get your binoculars. They're a beautiful set of Celestron binoculars, and it's a wonderful, amazing first step into the universe on your own. It's really cool. And the Goblin's here, another previous winner. Hi, Goblin. How are you? Nice to see you. All right, Stephen Jarrett. Hey, I missed you. Sorry, buddy. Stephen Jarrett's with us as well. Alicia, I also missed you. I'm sorry. Alicia, does Darlene know what you got? Or you know, she knows about the lamp, right? You told me about this moon lamp that you were getting. I assume that she knew because it was already set up, apparently. Yep. All right. Yeah, actually. All right, cool. All right, so let's, at 40 now, we're going to save this one more time. And we will then save it exactly as seen. Okay. I'm saving twice because the first one is called a FITS file. And that's a flexible format for astronomy, so we can actually do image processing. All the data is raw, so you don't see any nebulae in it whatsoever. You just see some stars. And what we do with the image processing is pull all that out, but pull it out in a way that actually makes the images look stupendous. And that's what that format does for us. It's a format used by astronomy almost exclusively. Okay. Okay, so we'll get out of this now and go to another object. And first thing first, we're going to go back into low light mode. And low light mode is good because then we can kind of use it like a little image intensifier finder view. And we'll go back to our beautiful thing here. And I want to try and see if I can reach this guy down here. Let's see what his altitude is above the ground. The altitude is... wow, that's pretty low. We can try it. We'll try this anyway, because I want you to see the beautiful colors in this. Then we'll come up here. All right. You look at the telescope leaning way over. Well, it's above the wall, so there it is. Okay. This is a planetary nebula. It's the end state of a star, about the size of our sun, slightly larger or slightly smaller. And this particular planetary nebula is neat because for its distance of just under a couple thousand light years away from us, the star can be seen in the center. That is the remainder. And you can kind of see it here as we zoom in. You sort of see it right there. All right. And I'm doing this just to check focus of the stars because sometimes we have to care. I could do my temperature conversion, see if it changes it dramatically. That kind of kept it the same. All right. So I'll show you what it looks like now when we actually do an exposure of it. And now what happens is when the star finishes using its hydrogen, the core of the star begins to collapse because gravity's winning out because it's not pushing out with the energy it used to have. And that energy of the collapse causes the star's core to heat up and send out this radiating heat and energy, which tends to bloat the star and makes it into a red giant. Bottom line is that over time the star pulsates and sloughs off and pushes off its outer layers, and we get a lot of the gas that we see here that was made with the star when it first formed. It was always just along for the ride. It never did any fusion, which is the power source. And so that is something that happens with stars. And with stars about the size of the sun, we get this process here. And we are doing a 20-second exposure now. And you'll see the result of it in just a sec. All right. We cleared the last one. And then you'll see this beautiful teal nebula and red nebula. And I'll explain what the teal color is that you see in just a minute, because we should see it right now. There it is. Okay, so let's get this in a condition that's actually viewable. First of all, let's color correct. A little color correction. Now, let's take down the brightness of that overall general brightness of that teal color. All right, and now look at this. Now we're seeing a very different view. All right, now if I do this, it's gonna probably bring that back up. What I want to do is I'm going to bring our black level to just before the peak so we don't start losing any data. But then I'm going to take this mid-level and drop it way down here, and that will really show you the colors. Look at that. So here's the Dumbbell Nebula. Now we only have 3 exposures taken here. They're all stacked on top of each other. And if we zoom in a little bit, now it's really low to the horizon, so we're not getting the best view here, but there is that star right there, that little dot in the middle. That is a white dwarf. It's very hot. The remains, that's the remaining core basically of the contracted core of the star, which couldn't contract smaller. Where if it did, it would become a neutron star. It needs more mass to do that. And if it was bigger still, it would contract even further to become a black hole. But that's only if it was much more massive. This star was about the size of the sun, so it only could contract down to a white dwarf, which is about the size of the Earth. All right, and the outer layers of the star were sloughed off, and this bluish teal color is caused by ionized oxygen, but 2 electrons in the oxygen were bumped to higher levels. All right, and those higher levels in the atom that they were sent to were just temporary, and then they came back down and cascaded back down to their original levels. And this, when they do that, when they absorb energy and climb, and when they come back down, they give off light. Oxygen electrons give off this green light when they release their energy back. The red is both neon and hydrogen gas, and neon is actually playing a larger role because it turns out neon is the 5th most abundant element in the entire universe, which is kind of cool. I just read that the other day thanks to Daryl. He sent me an article about it. I was like, that's cool. And the 4th most abundant element in the whole universe is carbon. The 3rd most abundant element in the universe is oxygen. So it stands to reason that life is going to be a carbon-based life with a high dependence on oxygen, and that's what we see on our planet, every single life form. Okay, so we've taken 9 shots here so far, and again, we're really low to the horizon, so it's not going to be as clear as it could, but that's okay. Notice this star here in the middle, it's kind of blue. And that's because the star is extremely hot. The white dwarf, the remains, it's no longer doing fusion like regular stars. It's just a hot leftover core that's slowly cooling over time. And this cooling, this star will eventually, the white dwarf will eventually become a black dwarf. But not before a whole nother lifetime of the universe passes by of 13.8 billion years or more. So this is cool. Okay, now Michael Galea asks a really good question. He says, compared to the star you're showing us, how will our sun end? Approximately the same way, Michael. This is something that happens to stars that are about the size of our sun. Okay, I'm going to bring this in so you can see that there's more stuff on the outside here. Okay, look at this. See this extra shells on the outside? So we have more stuff, and because it's glowing teal, it means that the area in space here, the atoms are being hit by enough ultraviolet energy that they are causing ionization to occur. Ionization only takes place when you've got this really, really powerful ultraviolet energy. Okay, so if there was any planets anywhere in this region, they would be sterile, with very little chance of life occurring on them. And if there was life, it would have been stuffed out. So, Richard McFarland saying in 6 minutes Europa will be passing in front of Jupiter. Yeah, that's going to be tough for us to see. This is a wide field scope, and Jupiter's really tiny. However, our next scope going in, if we can get funding, hopefully people can donate. We'd like to install it in February. If you notice up here at the top, it says, please consider donating to the cause at skytourlive.org. You can just do a donation of $1 even. You can pick your own amount if you wish. And you don't, obviously, we're not asking for people to donate or else. It's just, it'll help us get this telescope installed down in Benson, Arizona on this mountaintop. It's a second telescope we have. And that one is a magnified field system. So in that one, if we go look at the Dumbbell Nebula, natively it's going to be this big in the view. And then we'll be able to zoom in even more. Okay, I mean, this is what it looks like low to the horizon. It's not very good. So, but the point being, it's very helpful. And the other thing we're going to do, I did a color correction to get rid of the reddish hue there from the horizon. The other thing we're going to do is, for the first time in history, we're going to take a 3D image of the moon. We'll take a picture of the moon with this, a picture of the moon with this other thing, 200 and some odd miles away, and we'll make a stereogram of the moon. So when you do that cross-eyed look at 2 images of the moon, you'll see it in 3D. And that's going to be really cool. The moon is 2,000 miles in diameter. So 200 miles at its distance of 240,000 miles will be just enough to show it in 3D, and that'll be really cool. So we're trying to make strides, and that'll be kind of cool. I'm really happy about that. All right, so this is the Dumbbell Nebula, and I will annotate it and show you. I mean, I could type it in, but I'll let it do it because it will. So there's the Dumbbell Nebula. Okay, and I'll set that as our target, and our target name becomes that. Okay, I'll save it with annotations, and that goes out on the server as well. Now, when I say server, what do I mean? I mean, right now, this image I just took, and any image I hit save from, like when I say save right now, okay, you see the green bar? Where's that going? It says image saved. Well, this system inside the building where the telescope is now sending that out up the pipe in the internet, and it's sending it to our server at skytourlive.org, where you can go look at this image I just took and see it within 30 seconds of us taking it. I'm going to tell you right now, there's no one else doing this in the world. No one. What we're doing is wholly unique right now. Now, I spent 2 years developing a technology to do this, and so it gives us the ability to do it. And I had no certain return on the investment. I didn't expect, I was going to make millions of bucks, and I wasn't looking for it. I wanted to have a better way to teach astronomy to everybody, and I knew I needed to do it from an area in the United States where it was really dark and gorgeous, and that's this location. So we have a telescope in this location, and we want to put one in Benson, which is actually slightly darker than this location. And when we do that, we want to be able to, and it's higher altitude. The one in Benson's at 3,600 feet. This one's here at 1,900. So it's higher by a little bit. So just over 1,200 feet. So we want to be able to get some beautiful imagery there too. 25 shots, that'll do it. Okay, we'll save that. Save exactly as seen. Yeah, okay, so now that image is going to be saved to our server, so I can get rid of it and it won't hurt anything. Then we'll go back to our low light mode, and then we'll check that out. That's kind of what it looks like in a telescope. To your eye, you can see a little better with your eye. All right, now let's go back here and grab an object that I want to show you before we lose it entirely. We're going to look at a incredible supernova now. We looked at the death of a star just now in this nebula, and what we're going to do now is we're going to look at another death, a death of a more massive star. How do these more massive stars actually die? Well, this is how they die. This is a massive stellar cataclysm where the star itself is what we call disrupted or destroyed entirely. And that destruction occurs over a period of a few hours. Once the supernova chain reaction basically starts in the core of the star typically is bigger, massive, a supergiant, and so it takes time for the actual moving physical matter to get out of the star and breach the surface of the star, obliterating it. And that's when it does obliterate it, that's when we actually see that the supernova occurred. But prior to that, hours before, something that does get out of the star that we see are neutrinos. And these neutrinos are the things that will signal the onset of a supernova event. So when Betelgeuse finally goes off, I think there's telescopes that are watching Betelgeuse right now, and we're going to get a warning saying supernova coming, and Betelgeuse is going to go supernova. Hopefully it'll go this winter. That'd be kind of cool. It's going to be so bright you'll see it during the day. You will see it during the day in the sky. That's how bright it's going to be. And it'll be that bright for a period of a month or so, maybe a little more. And then it'll dim down. All right, so this is the Veil Nebula. This is the eastern veil, the side toward the east. And I'm going to just drop us a little more. I'll let this top part kind of drift off the bottom, off the top. And let's just do about one more little jog, because I want to show you the bottom here too. Okay, that'll be good. And again, this is a beautiful nebula. Again, it's going to be red and teal like this other because of hydrogen and oxygen. And what's happening is that material is moving out into the interstellar medium very quickly, and it's colliding with other dust and everything out there. And that dust is causing it to clump up in some places. That is the material that's expanding. And it's also causing the material to get very, very hot, up to 1,000,000 degrees. So as it does that, there's another Starlink satellite. As it does that, the materials, the gas, the ionized oxygen and hydrogen will glow in their respective colors. And right now, we can see that if we do a 25-second exposure, you're going to see the most beautiful Gossamer Nebula you've ever seen. Just a minute. So let's go into deep sky mode here and check it out. Remember, go to SkyTourLive.org for these images, or if you want to donate to us, go to SkyTourLive.org and click the donate button, or even join our Patreon. And get, for our Patreon, if you join our Patreon, you get some of these images highly processed, and you'll also be getting SkyTour swag, cups and all kinds of mugs and stuff. And if you really want to go, if you want to get some for Christmas, well, then feel free. Just go here, go to SkyTour shop on Etsy, and you'll be able to look at that. Look at that. I'm gonna remove this. It's gonna stay up, but I'm gonna minimize it so we can see the rest. And we're gonna move the telescope out of the way here, and just go full screen, because this is a beautiful sight to behold. Let's take a tour. Okay, look at this Gossamer Nebula right here. We are seeing these beautiful filaments. Again, look at these very delicate filaments. These are the result, and this is only a couple images that we've got stacked right now. We've got 2 images stacked. By the time we get to 6 or 8, it's going to be stunning, even more. And as we drag it down and look at the rest of this stuff, you'll see the colors are very rich. This is hydrogen gas glowing in here, probably with some neon. And then we see the oxygen mixed in. And it's just this gossamer filaments. We zoom in. Let's zoom in on that. Even though we only have a few stacked. And it's actually still pretty low to the horizon, but we're still getting a beautiful view of it. Look at that. That is just gorgeous. Really, really pretty. Really, really pretty. Karen Belmont asks, how big are white dwarfs? White dwarfs are about the size of the Earth. And a sugar cube size of a white dwarf on the Earth would weigh about as much as a car. Okay, about 2,200 pounds. Now, the next stage, if a star is more massive, it can shrink down to a size of a city, Manhattan Island, and that's a neutron star. A sugar cube size of a neutron star, on the other hand, doesn't weigh as much as a car. It weighs over 200 million pounds. 200 million tons, excuse me. Okay, so that's pretty heavy for a little sugar cube size, you know? But that's what you get with a neutron star. And the term black dwarf, last of Karen's questions, the term black dwarf, and they're all good questions, the term black dwarf means a white dwarf that's cooling so much that it starts to get cool enough so you can't really distinguish it between the rest of the interstellar medium, which is very, very cold, like minus 273 Celsius, which is absolute zero. So it'll be right around there or just above. Karen Belmont says, better than going to a planetarium as this is live. Yeah, it is live. You're seeing it as it happens right now. I always think about this funny stuff. If you look at this here, and you look at this object, the light that's coming to it is the light that our telescope captured. If we were looking the other way, it wouldn't have come to us, but the light was still coming to us. So it's light that's lost to time. This light has been captured for all time. That's really pretty. Look at this thing. That's a real nebula. Live Universe live in real time. Isn't that cool? That's really good placement too. And this is the eastern veil, the eastern side. Now, it's a big, giant spherical envelope of stuff moving out from where the star was. So, that is the debris moving outward. So there's some coming toward us, some going away from us, some going at odd angles, and some going to the sides. So some of this is going to the sides, some of that's coming toward us, and some of it's going away from us, expanding this way. You know, kind of cool, and that's how that works. You know. All right, so we have 10 stacked now. Let's see what our live stack data shows us. Okay, we've got 10 with no frames rejected. That's good. I use a full width half maximum filter. This is cool right here. This filter is very important because what it does is it shows us that our focus is really good. There's not a lot of wind. And so this dashed line is the threshold. Above this, stars could end up looking elongated, and we don't want that. So if we had an elongated star because wind bobbled the telescope, it would be a red block here, and it would not be used. Further, if a satellite just went zoom right through the image, that image is ruined. I just click back on here. I just have to click unstack, and it will unstack that last image. But we don't have to because we don't have any satellites at this point. Neat, huh? Isn't this cool? It's all free and it's live. You're seeing the universe live in real time. That's what I like most of all. The universe live in real time. And I really love these filaments. These filaments really show us a lot about the universe. You can see these really, really subtle filaments here of oxygen. And what's neat is you look at them and they've got some real definition to them. You can follow them down. You can follow the turns and twists of this one going in and out. Okay. So what does that really mean when we look at a structure like that? What we're looking at is potentially charged particles that are affected by the movement of particles through other charged particles. And so we might have an electrical component in this nebula, electrical currents flowing through this nebula that are actually responsible for shaping the nebula the way we see it. Now, that's another line of research going on right now, and I think that's pretty cool. It's a possibility. Yeah. All right, so let's see here. Looking in the chat, I don't see any questions here. You answered Karen's Black Dwarf question. Michael Glia says he was asking his previous question about the how the sun will end, because he was taught the sun would expand to take the inner solar system possibly to Mars or beyond. It won't go that far, Michael. What'll probably happen with the mass of the sun, the nature of the sun, when it goes to its red giant stage, it'll get there 2 times. It goes once when it runs out of hydrogen, and once after it runs out of the helium that it will then burn. Okay, but when it finally reaches that second red giant stage called the asymptotic giant branch, its maximum size then might take the whole Earth as well, but maybe not. We might have a star that basically never sets, because anywhere on the Earth we're on, even at night, we might see the glow at the horizon of that star. So it's going to be a very, very large area in our sky. Yeah, I was always fascinated and intrigued by the way the sun would end. But then again, I was going to be an astronomer starting at age 9. I knew I was going to do this, and I didn't ever waver. I'm a geek. Yeah, DK, it is awesome. Oh yeah, and then Karen saying, what about the asteroid that bumped us in Siberia? Yeah, that's it begins with a C, C something, but it doesn't matter because it was only 27 inches in diameter, so basically 3 inches bigger than 2 feet. But the speed at which it hits, I mean, they can hit it anywhere from 70 kilometers per second up to, much higher, about 4 times higher. Bottom line is they could go anywhere from 24,000 miles an hour to 161,000 miles an hour as they hit our atmosphere. And at those speeds, they'll get through the atmosphere in either 3 or 4 seconds at the low end, 14 seconds at the low end. And at the high end, they'll be through our atmosphere in about 3 seconds to the ground. But it's like hitting a wall, and so they tend to blow up. And that's what happened with Tunguska in 1908. A small comet-like asteroid came in, probably comet, mostly ice, came into our atmosphere, blew up at high altitude, flattened trees for hundreds of square miles around, and it was just incredible. James Hyatt's with us. Hey, James, how are you? Louis Todd, what's going on? Paul Atreides is with us. How you doing? And Paul's saying, what's the approximate distance of what we're seeing? Yeah, this is a great question, Paul. Thank you. We're looking at something that happened about 8,000 years ago in this supernova remnant, and it's about 1,800 light years away. It's the size of several full moons in size if you put them end to end in the sky. It's really, really big. If you went like this with your finger and went at arm's length up into the sky, all right, you'd be looking at something that can just about encompass it. It's pretty big. Line Cherry, this is the Veil Nebula, not the Eagle, but I know what you're getting at. You're saying so different views of the Eagle Nebula. I wish we had the Eagle Nebula right now. It's set already because summer's gone. Yeah, I gotta deal with that. I gotta deal with running a heater here in Connecticut all night long when I'm doing this. It's down there on the floor, and I'm wearing a sweatshirt on top of it. Even though we have the heater running, it's still not warm enough to take off the sweatshirt, but that's all right. All right, let me move this. Yeah, that's that blue streak you're seeing. That's actually a remnant of my light behind me. If I do this, you won't see it, but then you'll see me. Hi. So we'll have to deal with the light with that little blue streak. It's like Eddie Munster. Okay, so let's bring back our telescope for a bit. There we go. And now let me bring this guy back. All right. So he'll come back now. So this is our stack. We've got a beautiful green stack. All good. That's good. 27 shots. That's beautiful. And it's low to the horizon. So we'll say we're gonna annotate it. If it doesn't know what it is, we will add it in. It does know what it is, but there we go. Okay, this is the Eastern Veil right here, and we're gonna set the target name. Okay, and then we'll save the annotation. Good. We'll get out of here, and now what we'll do is save it and save it exactly as seen, and I'll show you what image is going up on the server. All right, this image you're about to see will be up there in about 30 seconds. All right, and that's the thing that is kind of cool. That'll be up there in about 30 seconds for you to take down for free. Okay. Now let's get out of this image and go back to our low light shot, because I want to show you the other side before we run out of altitude. Okay, so this next place we're going to go is right near it. Okay, so we're here in the Eastern Veil, and we're going to go now to this next location, which is even bigger. See, now you actually, this is the planetarium shot. You see, let me bring you over here. You see the entire sphere of the supernova, and somewhere in there is Cygnus X5, either a black hole or a neutron star, and it's probably a black hole, actually, X5, and it's the remains that left behind of this stellar explosion. But today we're going to go over here. We'll have 52 Cygni as our guide, and we're going to go there, and you'll watch our stars now move as we head there. And we're moving through the central veil, which is in between. There's 52 Cygni right there. All right, and you'll see this very faint ribbon. It's just beautiful. And this is something I'm going to move over a little bit. And the reason is because I want to show you some more of what's over here at the same time. So I'm going to move this a little bit out to the side. And you'll see a bit of the central veil right here. And let me, I guess I want to go up a little bit. It's going to cut off a little at the bottom, but that's okay. 'Cause I want you to see the top. All right, so this will be good. All right, so now what we'll do is we will go back to another 25-second shot. Okay, and we're on our way, off and running. And there is our frame counter going up. We'll come out of low light mode and head into deep sky mode. You'll see the previous shot. This is the eastern veil that we shot moments ago. And now we're shooting the western veil, the other side of this entire region. So we pull this down so you can see the whole thing. This new one coming in will overwrite it, so we'll be fine. It's not going to overwrite it on the disk, it's going to overwrite it in the buffer. Okay, so then the next image is this one, and this is the eastern veil. And you can see there's other stuff in here. It's all the interstellar remnants and debris of a supernova explosion. And this looks like, Daryl's always said this sort of looks like a cosmic tornado, you know. I liken it to a fire tornado because it's very hot and ionized gas. This star is actually a foreground star. That's way up here in the foreground, and the nebula is way back here. So they're not even remotely near each other. If you went by them in space, you'd get past this star just quickly, and then you'd be onto this. Judy M is with us. Hi, Judy. Richard McFarland says, what scope do you have? Okay, that scope we're looking at right here, Richard, that's a 10-inch Medelec 600 that's been modified from a photographic speed of f10 down to f1.8. So we have 25 times the speed. It's very, very fast. So it's nice. Hello, Prow. Prow's with us. So, Richard, make sure you email. Don't forget, SkyTourLive.org. Send me a message. Let me know where you are sending these binoculars that you won last show. Okay? Don't forget. We want you to have your binoculars. Okay. So let's zoom in on this. Now, actually, first of all, let me color correct it. All right, just a little. That helps bring out nebulae detail. And then let's actually do this, which is going to brighten everything and show you all this stuff I was talking about. So there is the western veil, and there is the central veil in here. There's a lot more. This is the part of something called Pickering's Triangle. It goes way up out of the view. Okay. But you can just imagine it, that this one here is moving this way. The western veil is moving that way. And this stuff here is either coming toward us or going away from us. But it's literally all spherical stuff. It's pretty cool. Thanks, Richard. Because we want to send you the binoculars. We've been waiting for you to come in. I'm glad you're here tonight. Thank you for coming in. I also put you on the webpage so you can see Richard McFarland listed. So you scroll down at SkyTourLive.org and you can actually see the past winners. And you're in the list, man. So is Karen Belmont. Okay, and now we got this beautiful teal color. Let's zoom in now on this. Now we have 6 images stacked here, but that's enough to have some fun. And what I'll do is I'm going to make the background. This is a black level line, so we pull this up this curve. This is the average of the red, green, and blue curves, all right, from the sensor. So the farther up this curve we go, if we get to the top, then we're just cutting off a little of the data, but just before the end, the top of the curve, that's the best spot for the darkest. And this is going to help us cut off brightness so that we can see deep inside. This is very, very bright, see? But if I bring it down here, now you're going to see, oh, look at how gossamer that looks. Now we can actually see the detail much more clearly. It's really cool. But I'm going to show you something that we did in astronomy. It's something I've done in astronomy for years. We sometimes look at nebulae like this, okay? We look at them in black and white. And they wouldn't look like this, okay? This is color negative. We'd look at them in true black and white like this right here. And this would help us study the detail that we're seeing in the nebula. Yep, there we go. Okay, now let's see here. Let's see, now we get here. So we'll let this come in a little bit more. All right, just saying a message here. Okay. All right, so we'll bring this back to regular light and back to full color. And we used to take photos in black and white too, but if you notice, the black and white wouldn't help us discern the oxygen that's ionized from the hydrogen. Only color will do that, or filters. So we would use filters to look at only the oxygen or only the hydrogen, and then we would see just separate bands, and we'd have to combine them. But that's something that astronomers have done for a long time. Look at that. It's just such an incredible sight. This is 12 images stacked with no problems. Let's look at our all sky, see what we got for the weather. It's looking good. Here's the Pleiades right here, the Seven Sisters. Here's the Hyades with Aldebaran, which is much closer. And there's Orion. Orion's belt there. My limit on the, if you look at the, when you look at the observatory, there's a wall, there's 4 walls. My limit on this wall is right about here. So I can't see below that. But if you notice, I've got the dim light that you can't see with your eye, but you can see it with the cameras like this. We have the dim light of Phoenix 75 miles away. And I don't take photographs over there because of that. I don't want to get that polluting my images. Hey, William Connolly, how you doing? Nice to see you. Okay. Yeah, so this is our beautiful Veil Nebula. This is the nebula that is on the western side. And you notice all the stars. Remember, this is 3-dimensional. We're seeing this in all manner of configurations. We don't know what's coming toward us or away from us like right away. You know. Okay, 1 second. I gotta send a message. I think we have 40-mile-per-hour winds coming in tonight. Not out the observatory, but here. All right. This is 17. And we will save it anyway. Why not? and then save it exactly as seen. And then I'll click on it and show you what you're going to get. So this is the image that you're going to have right up there on the server right now. Central veil right here. This is Pickering's triangle, the beginning of it. It goes further up. And then these beautiful little pieces of debris. And this stuff expanding outward. Again, electrical charge could be responsible for shaping these tendrils that we're seeing in there, those little tentacles. Really interesting stuff. Yeah. Okay, let's see. Hey, Stuffy, how you doing? Lewis asked, is that the dust from the Milky Way? I'm thinking you're thinking on top instead of PM top. I'm not sure if you meant on top. This is what I think we're looking at. You're probably looking, if I recall, you're probably looking at this. This is the Milky Way right here. The summer Milky Way is setting. This is the west over here. See west, so this is west. This is the moon setting over here, so that's what this light is. Otherwise, it's pitch black out here. When there's clouds in the sky, we see they're illuminated to about here, and then from here over, the clouds are black against the sky. So it's pretty dark out here. About halfway. You get a little bit of illumination on the bottom here, but over this way, they're all black. This is a rift in the Milky Way here that you're looking at. Really cool. All right, so let's pop out of this and go back and check. Oh man, this is just getting prettier and prettier. Let's zoom in again here. We have 22 images stacked here. Look at these fine tendrils. Look at those. Those are incredible. Fine lines all the way through. Amazing. Wow. Let's color correct and see if we need to do color correction. Yes, a little. That helps us get the colors correct. I want you to remember this color. This is a color that's going to figure prominently in several more objects that we're going to see as winter approaches. Okay, it's the color of ionized oxygen, where you have two electrons that are bumped to higher levels, and when they drop back down to those lower levels, they give off light. And when they leave the atom entirely, then the atom is charged, because right now, when an atom has all of its electrons, there is zero charge net on the atom. Right? You have say a hydrogen atom that has one proton and it has an electron. Right? Well, the electron's -1, the proton's +1. They cancel out, so the charge on a neutral atom is 0, and that's what we call H1, Roman numeral 1. If you add energy into that atom, the electron absorbs that ultraviolet energy and bounces off the atom, and now the atom no longer have an electron, and so it's a +1 charged atom. It's just the proton. All right, it's the nucleus, the atomic nucleus running around. And when that electron finally, after hitting other things outside the atom, loses some energy, it falls into the atom again. And when it falls into the atom, it gives off light. And that light, the predominant light, in fact, that hydrogen atoms give off, is this red. This red glow you're seeing here, not this halo, that's an artifact of our system, but this red glow that you're seeing here, this is the diffuse glow of hydrogen ions that are having their electrons recombine with them, and thus that is the red glow you're seeing. Neato. Very cool. All right, 27 here. That's good. All right. We'll save exactly as seen. Okay. All right, this is out there. So this is a supernova. It's the remnant of a star that literally is no more. It blew itself to pieces when it ran out of hydrogen, then it ran out of helium, then it ran out of carbon to make into nitrogen and oxygen. It ran out of oxygen and fluorine. It ran out of everything all the way up until it got to iron, where it couldn't go any further. Iron is the tipping point. It can't fuse past iron because it takes more energy to fuse iron than the star has to give it. The star can give it. So we end up finding that iron is the end result of that. So that is why we end up with iron as the last element in the supernova. The iron core, iron and nickel in the core. Okay, so now over here, right, another beautiful object is the result of many supernovae, but not a supernova remnant itself, but the result of supernovae is this one that we're going to, and it's just north of Cygnus. You'll see the stars zinging by as we whip our way over there. You can see the telescope moving up there until finally we get to this object here, which of course you can't see what it is because we have to do a time exposure, and we shall do a time exposure. And I'm going to just quickly run into our view here and zoom in, and you can see this square box, and you notice the writing sideways. If you look at it the right way, this is the writing. This is the size of our field. That's the size of this square on the screen. So this represents what we're looking at. Okay, and we're seeing this cluster, and in that cluster is these artifacts we see here. And I'm going to move this up to about there so that we can see them much better. So we're going to move this down. Okay. And we're going to move it to the east a little bit. Oh, yes. This is going to be... Oh, I meant to go to the west a little bit. I apologize. I meant to go the other east. Okay, to the west we go. Okay. And now we look back here and you'll see where our telescope's located. It's located here, and we center on that, and that should be just enough to show us what we want to see here. Move it up a little bit so you can see how it relates. Okay. All right. So this looks like it should be good. So we're going to have a dark object up here, dark dust object. We're going to have a interesting piece sticking out here. That's the elephant's trunk. All right. And then we will be able to see some dark nebulae and other stuff. Actually, this is the first time I've imaged this with our camera with its new settings. So this ought to be really fun. Let's do 25 seconds here, or 25,000 milliseconds. But before I do that, I'm going to do the annotation. And it will, there it is, it'll have it right there. Let's see, Elephant Trunk Nebula, and we'll set the target name. All right, and then once we get some imagery in there, we will come back and actually re-annotate so you can see it on the server when we get it done. Okay, so we'll come out of low light mode, go into deep sky mode. And the last image we did was of the western veil, which you see there, and we'll clear that. That's just beautiful though, huh? It's just beautiful tendrils in there. Okay, so we'll clear it now. You don't have to, it'll be overwritten by the image that comes in. So here we go, and now we should see our first image, and there it is. We'll zoom out a little bit, and I told you about that dark thing that was going to be there. Here is the elephant trunk. It's beautiful. We're going to color correct. Okay, that's going to change something drastically, and then we will do a process of the darks and the lights. And now you see the rest of the story. And now what we'll do is we're going to move our dark curve to near the peak. So we're going to get some contrast out of this. Look at that. So this is a stellar nursery, and it's also a location where there's lots of dark nebula. And I've said this often to people, and that is that life began in the dark. Life began in the dark. And so it is within these dark clouds that are like minus 250 degrees Celsius, which is, and just a few degrees above absolute zero. Absolute zero is minus 273 degrees Celsius. All right. And in the dark here, these dust grains are extremely small, micron sized, and millionth of a meter size. And basically, they have little tiny pieces of ice on them that are water ice, methanol, carbon dioxide ice, ammonia ice, and they have carbon monoxide mixed in. They have oxygen. They have carbon mostly, silicates, silicon, and so that is the basically the lifeblood of the universe. It's the stuff that from which life is made. So it's in these dark clouds, in that chemical slurry, that chemical soup, in those dark clouds, where life begins. And when it begins there, it may begin with the spawning of a star. And when it spawns a star, then that star may end up having planets around it. And if we look here in this elephant trunk, we won't see planets per se, but what we can see is inside this loop, this big giant trunk-shaped thing, inside this, we see a star. And it looks like it's got an opening around it, like it's cleared a path around it. And in fact, it has. This star has opened a cavity like stars do. Young clusters will open cavities around them. This star did. And so you can see that it's light in here because the star is ionizing some of the hydrogen in here. It looks a little more red than normal because of the dark dust between us and it. It still has dust between us and it. But boy, oh boy, this is a amazing location. And here's another piece of that whole dark cloud. This is actually known as the caravan, and this is the elephant trunk. So you can see it better now. And it's actually silhouetted against the stars that are causing this hydrogen to glow, which can be further in. They can be visible. They cannot be visible to us because they might be in the dark, hidden in there. But the ultraviolet energy is causing the hydrogen to glow in this region. And we can drop this back just a little bit so you can see a little more where that's coming from, how that works. Okay, so I dropped this back and you can see a little more detail in all this cloud. There's a lot going on back here. All right, so if we just pull out of this and just open it up, you can see what we're missing right here. We zoomed all the way into that little tiny dot. And because we have a tremendous dynamic range on this camera, we can zoom way in. Okay, this right here. This is 100% of the sensor. This is its native magnification. All right. Yeah, we're looking at it from way out here, and it's still beautiful. Isn't that gorgeous? That is just gorgeous. So this is the Elephant Trunk Nebula. We've got 10 shots taken. We'll save it. Save exactly as seen. Then get our annotation up and running and save that again. Save the annotation. Nice. So this is the image for the annotations that you get on the server. This is what you'll get. You'll get all that. All right. And then you get the image without it, with just this detail that you see without the writing. The unannotated version too. You get this version. Wow, it's cool, really cool. Let's go back here for a minute. I want to try something. I want to look and see. I want to go back and see if on the other side we've got the possibility Let's find out. Let's do this and see where it is. All right, what's its altitude? Altitude 37, not quite high enough. Hey, Hunter, welcome home. My son just got back. Okay, not high enough yet. We have a wall, and the wall in the observatory looking north comes up to about here. So we're not quite above that stuff yet. We can't see that yet. But we can see the Pleiades, and I'll show you the dust cloud around the Pleiades as well. Because that's beautiful as well. And that's the dust that we might be in. Richard, go to skytourlive.org. Actually, you know what? Let me see if I can actually do that for him. Just a minute, Richard. We're gonna show you, Richard. Richard's trying to find the email. I say, sorry, I can't find your email. We'll fix that. Let's see here. Okay, so when you go to skytourlive.org, Richard. Okay, whoops. Get out of there. Okay, and let's do it this way. SkyTourLive.com, SkyTourLive.org. Right there. See this? Call us, email us, click email us. Okay. And that's going to bring up your email client. And it's going to have ContactSkyTour@gmail.com in the entry. And if it doesn't have it there, then you can, let's see, under more, is it? Contact us. And then the contact us form, you can do it here as well. Okay. So that's how you find us. All right. So once again, from the main page, you can email us, and that should take you right to our email. And if it doesn't, then it may not even say more. It depends on how big your screen is. If your screen's like this big, you may have this already there, and you can just say more and hit contact us. All right. And then that brings you to this contact form. All right. No worries on that, Richard. I know that it's, I didn't think that was a problem to find it, but then again, I'm making it sound easier than it is, I guess. So there. Excuse me. Okay, 18 shots so far. Okay, this is the Elephant Trunk Nebula. All right, we'll do 20. We'll get to 20, and then we'll go to the next object. The elephant trunk is several thousand light years away, so you're actually seeing it as it was thousands of years ago. That's what I like about the universe. It's a time machine. Everywhere you look, you're seeing things at a different time. You know? You're seeing Pluto as it was a few hours ago. Okay? You're seeing Mercury as it was a few minutes ago. Venus in the sky at sunset tonight. A few seconds ago. You know, and so it's a big time machine. Okay. All right, so we save this. So we're going to jump out of the nebula and go back to our low light mode. And after the low light mode, we'll be able to head to another dusty region of the universe. That's going to be spectacular. Okay. So we're going to take a drive over to the Pleiades to show you the dust clouds around the Pleiades. And keep in mind that even though they're 400 light years away, and you'll see the telescope going to be heading all the way over to the other side of the sky. Okay. Not yet, you won't, because I got to do this first. There you go. Okay. You'll see that you're going to actually see the Pleiades come into view here. you can't miss them because they're very bright. And there we go. Look at how bright they are. You can even see the dust clouds around them, and even here at this very quick 1 second shot. Okay. So now we'll head north. Okay. Head up north. That is Alcyone, that beautiful multiple star there. And then we'll head east a little bit. Okay. And we'll just drop it down just a little bit. Okay, so this is Atlas and Pleione. This is Alcyone. This is Merope. Not sure what that is. This is Maya. And Electra. And I can't remember the other name. But these stars are very, very bright. Also, 1, 2, 3, 4, 5, 6, 7. The 7 sisters. And they are beautiful. You may recognize that shape. It looks like a tiny little dipper to many people, but it's on the front of every Subaru car, because that's the symbol of the Subaru, is these typically these 5 stars here. There might be this one in there too. They might include one of these other ones. I don't remember. But the Subaru means unity, and it has to do with the stars being together in space, going through space together. Hey there, Mr. Django. Nice to see you. And you're welcome, Richard. Let me know if you have any trouble finding it. And Mr. Django is like saying, hey, your voice is still a little rough. Yeah, well, I came back from Arizona on the plane, and people were sick, so I ended up getting sick. I'm over it now, but it was really, really just problem. Anyway, let's see. Let's look out. Let's do a for this shot here. 20 seconds should do it. 20 seconds should do it. So 20-second shot, and we'll come out of low light mode and go into our live stack. Our previous image of the elephant's trunk will be in there. That's up on the server. We can actually increase. Actually, it's gone because we have the other shot coming in. So you'll see the dust around the Pleiades stars now that we were just talking about. Look at that. Look at all that dust. Isn't that incredible? Let's color correct that. There we go. And let's shrink it a little bit. And now you see this incredible amount of dust. Atlas and Pleione don't really have a lot there, but you see some out here. Alcyone has a bunch here and out there. Merope, this is the most beautiful nebula because it has this combed look like to it. See that? It looks like you combed some hair, and that's the brushed look of Merope. And it's nebula, all in here. Okay. Then Maya up here has this really large curved nebula. Now here's what's going on with these stars. They're traveling together, moving amongst each other a little bit, but they're traveling through a dust cloud. These are not the dust they were born in. This is a dust cloud that they're traveling through. And it might be a dust cloud we're in. So that's cool. So this is 400 light years away. And again, these stars are all B-type stars. Massive stars. And they may end their lives as supernovae. Although right now, they're fusing hydrogen into helium. I'm going to confirm that, though. Let me go look at them. And look at their stellar types. Let's start with Alcyone. Okay, Alcyone does it have a speculate? It's a giant. It's a B73. So it's already past its hydrogen fusion stage. So it's heading toward potential for a supernova stage. And then this is Merope. And Merope is... It doesn't have a spectral... Oh, yes, it is. Okay, this one is a B6, and it's a 4. So it's a subgiant, which is interesting, meaning it's on its way to giantdom. But then we have Atlas and Pleione. Okay, this is Atlas here, the brighter of the two. This is Atlas right here. And Atlas is a giant star as well. It's a B-type star, but it's a an extremely hot, bright B8 star. B0 through 9. They go A0 through 9, O0 through 9. So O, B, A, F, G, K, M all the way. And so it's a B-type star that's extremely hot, and they're giving off a lot of ultraviolet radiation. And if there was a lot of hydrogen here, we would see hydrogen diffuse nebula, the red glow that we see in some places. But we don't, because this region is somewhat devoid of hydrogen gas, and so we don't see it here. All right. Now this, Maya is a giant as well. And then we have Electra over here that I mentioned. Electra, again, another giant. And it has emission lines in it, and so that's actually a very interesting finding because it shows that Electra is further along in its evolution. And then we have this one here, and this star is interesting because Seleno is, again, one of the main stars of the Pleiades. It's the only one that is just doing normal hydrogen fusion at the moment, because all the others are doing their end-of-life stages. Electra is still in its prime. Seleno is still in its prime, and is a star that's actually fusing hydrogen into helium still. Now that may be only for a short period of time. No, I'm wrong. Seleno is a subgiant. My mistake. Okay, ignore everything I just said. Only about Seleno. And then this one, okay, is another subgiant, Tegeta. So there's actually over 1,000 stars that are actually part of the Pleiades, and probably all the stars we see in here are part of this Pleiades cluster. But these are the giants, the standouts. Okay. There's some other bright stars in here, but these guys are the standouts that everybody's so used to seeing. Very nice. Again, there's that brush look and zoom in on that. We've got a lot of frames that did not get captured here. And that's because this was not... I should have been higher, but that's okay. We'll still save this. I'm going to do a annotation here. And we'll say, let's see if there is one that just says Pleiades. And maybe, there it is, Pleiades, right there. So that's Pleiades. We'll save the target name as that. And then I could have just written it in, but I'd rather just do this. And we'll say save. And that's cool. Alright. We don't need to do a lot with the Pleiades. That's neat. Save exactly as seen. Alright. So again, here is the image you get when you go to the website. That's the image you can download. These round halos we take out when we start processing. Okay, that's one of the things you get as part of the Patreon, is we give you highly processed images. And we're also going to give you some swag from our SkyTour shop as well, mugs. We have sneakers with Nebula on them, mugs, drinking glasses, water bottles of all kinds with all of our imagery on them, and they're just really pretty. They're highly processed as well. We got playing cards, coasters, oh, you name it, we got it. It's got clocks. Clocks are really cool. Neat stuff. Lamps. You should see that we do a Nebula, a red Nebula lampshade. It's a real Nebula we took a picture of. I think it's the Flaming Star Nebula in Auriga, and we make that into a desk lamp on the shade, and it just makes this beautiful red glow through the room. It's gorgeous. It's not what you're seeing here. I have programmed Wi-Fi lighting so that when I stream, I have the blue lights behind me and a red light overhead, just to make this section of the office my red light district. I don't know. Anyway, okay. All right, so that's pretty cool. So the Pleiades cloud of dust then is something that we may very well be in. And that's a really cool finding, and there's doing more research on it to figure out just how true that is, or to what extent, because it looks like we are in it. All right, let's go back here. All right, so that's about as low as we can go. We might. Oh, actually, we could probably do this guy, the Flaming Star. This is nice, because I will show you the nebula that's on our lamp. Actually, yeah, it should be within sight. Right over here. So let's annotate it and do a solve for nearby. Okay, here we are. All right, let's take this star here, and that will be 24,727. Center that. Okay, and while it's centering, let's go over here and go down here. And zoom in. And let's find that star. Okay, that's, oh wait, let's go here. Let's get that star. That's 24,575. So that's got to be right nearby. All right, 24,575. We'll find it because we can. All right, let's see here. Go here. And do this. Move to it. Let's see where we are. That's probably going to head this way. All right, let's see now. 24,789. Hey, watch it. Go jog. All right, and do this. Got caught behind. All right. 839. Let's see where we are here. $24,799. Yeah, there we are. Okay, that's what I saw. All right, we're close. We're there. So it's sort of in our view. Let me move it here. These guys. My park is $24,799. It's right there. Okay, and then that one is going to be 17. Oops, sorry. This guy. 17 Ariga also has 24,740, which is right there. Okay, so what I'm going to do now is I'm going to move this feature into our view. So I'm going to move down and a little bit to the left in the view. So let's go down and to the left. Take this just almost out of the view. And now we're going to go east. There it is. Okay. All right. Okay, and this is the Flaming Star. Interesting because it has a whole... I never used to like this nebula because it was like, oh, the Flaming Star, how boring. As it turns out, it's not really boring at all, as you'll see. It's really got a lot of really cool nuances to it. Yeah, all right, let's do this. Right about here. This will be good. Okay. We'll come back and do annotations in a minute. So you don't really see much right now. But after a 25-second shot, where you're letting light fall on the sensor for 25 straight seconds, what do you do? And let's do that. So there's 25 seconds. Go into our stack. And you'll see our previous shot of the Pleiades. And you can stare at that for a minute until the shot of the Flaming Star Nebula comes in. Hey, Tricia. Tricia Ferrer's with us. Hi there. Really good to see you. Okay, and there we go. So this is the Flaming Star Complex. And what's interesting is it looks like a star that is literally a flame, which is kind of interesting, right? Because stars are. Let's do a color correction first to stabilize everything. And you'll see there's a lot of blue in here as well. Okay, and you got this tendril sticking up, which is cool. Let me see here. Are we looking at the right thing? I'm thinking those are the tadpoles. I'm not sure. I might be looking at the wrong thing. I think I'm in the wrong spot. But you know what? It's okay. I might have... Oh, I did. I dropped this the wrong way. My mistake, guys. But you know what? I went the wrong way. But that's okay because this is another one that we want to see. This is called the... it says the letter Y cluster, but what's actually in here are two other objects. These guys, these are tadpoles. They're called the tadpole nebulas, and they are really something. Let's annotate this because those are going to be there. Yeah, IC 410. Okay. So IC 410 is what we're looking at right now. We'll save the image with the annotations. Actually, let's grab that and we'll set that to be our target name. Save image with annotations. Then from here, it can take us to the next object, the flaming star. All right, so we'll come out of this now. All right, good. And we'll zoom in a little bit too. This is another area in the sky where we're seeing stars being formed. You can see some oxygen clouds here. They glow slightly teal blue. Those might also be reflection nebulae, because there's a lot of dark nebula in here. This is all dark dust. I think it looks. I know you think it looks like a void in the stars, but it's not. This is actually dark dust, and that's not everywhere you look in the sky. Okay, but in the Milky Way regions, there's lots of dense dark dust in the Milky Way. This is dark dust, not a hole. Okay, this is dark dust, not a hole. And you can see that when you zoom in really close. Now, we only have 7 images stacked, but you can see that this is sort of in front of the bright nebula behind it. It's up here, and the nebula's back here. And here, in this case, you can see how you have some emission, some hydrogen nebula that's sort of over the dark nebula. It's sort of over the top of the dark nebula, and that can happen too. When it depends on densities. The hydrogen is much denser, so it looks redder. Okay, in lighter densities, it looks lighter. Dust can look blue when it's reflecting light back off the stars that are hot in the region. The blue light is the light that gets scattered by the dust. Red light doesn't. So all the rest of the colors come through, and the blue light gets scattered. It's momentarily trapped and sent out, reflecting in every direction. Now you see that on Earth too. I've said this 1,000 times to you, I think. Here on the Earth, we see that exact same process. And it's the reason why our sky is blue. Because the molecules are trapping the blue light for a moment and then sending it out any which way it wants. And that's why the sky looks blue in every direction. Because everywhere you look, it's just going to be all over the place in the sky. Stephen Jarrett says, Mark, your coast-to-coast talk, when is it, or did I miss it? Spacecraft travel through mini black holes, the subsequent... Oh, yeah. Yeah, that's on the 10th, so you haven't missed it. That'll be on the 10th with George Norrie. Looking at my schedule, let's see. This Saturday, on December 6th, I will be doing a talk for the Connecticut MUFON up in Windsor Locks, Connecticut. December 9th, that'll be at, that talk will be at 11:30 to 2. December 9th, I'll be on Don Ecker's show. Don Ecker is a former detective and a really good friend, a good guy, and he has an excellent show. That'll be at 7 p.m. These are all Eastern time. Then Coast to Coast is the 10th, and that starts at midnight Eastern time. Yeah. Yeah, so that's pretty cool. And then the 11th through the 14th, I'll be working with Ben Hansen, a good friend of mine, who's flying out to Connecticut to do an investigation on a case, and I'll be helping him with that. So it's pretty cool. All right. What do you mean, Ronald, you missed this show? You didn't miss it. You're here now. I'm seeing you right here. Ronald is ERRT Radio. He has got a channel. He's got his own website, too. Ronald, stick up your website so people can see it. Music-oriented. Ronald's a musical kind of guy. Oh, good. The Goblin likes Coast to Coast. Well, I'll be on there on the 10th with George Norrie there, Goblin. So you can listen if you want to. Throw things at me, you know. All right. Ronald's a big supporter. Ronald, the ERT, is a big supporter of our channel. I want to thank him for that. And we got other supporters here as well. Yep. Okay, so we've got 15 shots here, and you can see this feature known as the tadpoles is developing nicely. Let's do this and see what it wants to do. Okay, there we go. I'll pull us in. Let's go just past the peak, just to darken. There we go. Now you can actually see some detail in those things. Really cool stuff. Really cool. Excellent. Goblin will be listening. Good for you. I'm looking forward to it. Steven, I can do, I mean, I'm in Connecticut, but I'm in Arizona all the time. And I often drive to Palm Springs to do conferences there. So that's not a big deal. I can go up to the Bay Area. I can go all over California if they want me to do something. I actually do sky tours. Like you see right here. I do this remotely. I've done them in Roswell. I've done them in Palm Springs. I've done them in Danbury, Connecticut. I've done them in various places in the United States. So I can take people on a nightly tour. It's really cool. It's like a sky watch where you don't have to go out and stand in the cold. You know, you can sit there, you can sip your beer with friends and watch a sky tour develop. You know, and just have a lot of fun. I prefer those because people can order food, sit down and eat, and watch a sky tour on the big screen. It's just the coolest thing. It's live astronomy, man. C&D boy put up your link there, Ronald. I think that's cool. Which university is it, Stephen? I also do talks on extraterrestrial intelligence and UFOs, things like that. I'm the chief photo and video analyst for the largest aerial anomaly organization on the planet. And that's the Mutual UFO Network. I've been their chief photo analyst since 2008. ERT radio, that's Ronald. He says California had a big earthquake. Actually, it was off Eureka. It was a shallow earthquake, not very deep. And it looks like the fault slid side to side rather than, drop. So the tsunami warning was wise, but unnecessary in this particular case, which is all good. Unlike the Fukushima earthquake, where a crustal plate rose. It was a thrust plate, and it actually thrust up, and that, since water's not compressible, it pushed this big bulge of water up. Think about all the weight that Earth's crust is pressing on to make that water bulge go up that far. That's massive. Okay, so this is 23. We're going to go to 25, and then we'll move on to the flaming star. So to get to the flaming star from here, right here, we are there. We're just going to end up going east by a little bit. No, west by a little bit. And then we have to go north a little bit. Let me just zoom in on this. Here are the two features we're looking at there. I'm going to do this. I'm going to set it right to this. Alright, so we have set our center point right here. Choo, choo, choo. Yeah, there we are. Okay. Yeah, all right. There we are. So from here, we are synchronized with the sky. It's like I hear songs like this playing. It's like I gotta pull out my guitar and I want to play like along to the blues here, you know. This is the kind of stuff I do. I like that. Sometimes a little faster, you know, a little more pizzazzio. All right, so we're at 28, and I'm going to save it here for final time. This is, let me make sure I got that right. I think I do. Okay, so we'll save it again. It won't save the imagery over this. That's the annotation that it's not going to save. And then I will save it exactly as seen. All right. Okay, and so now from here, we'll wait. Give ourselves our low light mode. All right, in our low light mode now, what we're going to do is come back here to our beautiful planetarium and pick this star right here and tell it to go there. So we're going to head over to that star right now. And we'll see those two stars. All right. I think they're over here. And I'm going to just confirm that. Yeah. Right. So that is the flaming star region right there. So what we're going to do is head north a little bit. Those bands are just momentary. Okay. Let's do that. Now let's actually head west. And then come back here and let's find out where we are. Do this nearby. There it is, dead center. Good. Okay, so we are going to take the image of the flaming star. And I think you'll find that it's really quite interesting. So this is the star, and you're going to see what looks like flames rising off of it. It's actually kind of a cool illusion. All right, so this is a 25-second shot for us. And we're underway. And we'll get out of low light mode and make our way to our deep sky mode. And that is the tadpoles in the letter Y cluster. And that'll be replaced with the flaming star with its beautiful blues and reds. Oh yeah, look at that. So here's the star, and it looks like it's got these weird flames coming off it. It's just incredible. All right. And let's pull this back of our curve a little bit. You can see so much going on over there. Let's color correct everything. It's going to change our redshift a little bit. There we go. Look how beautiful. That is stunning. Wow. And this will show us and now again we have two images stacked here, so we've done an image sandwich of two, and by the time we get to about 10 in these 25 seconds, you're gonna see so much more detail in here. It's really something. We can start zooming in anyway. This region is a region of hydrogen mixed with dust. So the difference between the ionized oxygen we talk about, which is teal, and the dust, which is scattering the starlight that's blue only, is that the blue light in that case is really a very blue color. It's not teal. Teal is a bluish green. That's a combo color. And the bluish colors are true reflection nebula, what we call these scattering points in the sky. And you can see the boundaries of the dust, where they're denser, they overwhelm the hydrogen that's emitting some light. So you basically see a combination of the two all mixed throughout here. This almost looks three-dimensional, this piece right here. It looks like a dark shadow, and it looks like a light front. It's not actually, it's an illusion, because this is just ionized hydrogen in front of and part of a dark nebula that's here. And where the hydrogen is denser, it shows brighter. And so it kind of gives the illusion of three dimensions, because that's what we're used to seeing. Cool. Neato. Lewis asks, which one was the previous one that looks like a dragon? Tonight, you mean? If you're talking about tonight, we're looking at the letter Y cluster with the nebulas called the tadpoles, which are in the upper left there that we saw. But in the summer sky, we do look at the Chinese dragon, which is to the left of the Lagoon Nebula. I never knew that was there, and when I discovered it, I was like, wow, there's so much more here than I realized. Hey, Ray is with us. Hi, Ray. It's cold where Ray is. You're in Pennsylvania, right? 25 degrees there. Clouds rolling in. Ugh, he has a Sea-Star out. Sea-Star is a really cool telescope for people that, want a telescope that can show them some, pretty interesting images, It's a small lens on the front, small objective lens, but it's still for people that want to learn about astronomy and catch something without having to learn how to operate, $30,000 of telescope. That's Sea-Stars for you at $500. And do remember, if you go to skytourlive.org, you can, try and you can go ahead and give us a donation. We'd love it. If you want to do it in an ongoing way, you can join our Patreon. And if you join our Patreon, you will get things like this nebula fully processed. And you get 4 images a month at the lower tiers that are extremely beautiful. But we're also going to arrange to get you some swag, and that is from our SkyTour shop. We're going to get you some things from our SkyTour shop for the upper level guys. Looks like we got our spider or something back here. Look at this. In the building. We do end up with spiders. I had a black widow crawl in front of the camera many times. This isn't the spider though. It looks like maybe something else is blowing in the wind there. but you can see there's wind. But our telescope is not feeling it because we stabilize with this system here. So I'm going to drop this level down and make sure we don't get any errant shots. So we're staying between 7 and 8 and pixels, and that's good. And this graph shows how the guiding's going, and we've had a few outliers here, but those were all processed and handled. And then we have this graph which shows the drift overall. So we're up to 14 images, and we can now zoom in more and see a little more of the detail going on this flaming star. There it is. Look at that. Looks like it's leaving a trail of smoke behind it. So these hot stars are actually causing this nebula to illuminate in all likelihood and glow. And where the hydrogen is denser, we'll see a brighter glow, like up here, all right, and here and here. Where it's less dense, we'll see a more diffuse glow, like here. Very nice. Ben Izabela, how are you? Nice to see you. Benjamin Izabela is with us. Whoa. He says it's 19 degrees where he's at. That's cold, brother. What are you doing outside? Hope you're not outside. I got a wood stove over my head in the big room, and at the other end of the house, I've got a pellet stove. So I got 2 levels of heating to this house. So after I do this with you, I'm going to be heading upstairs. This will be the last object for tonight, because then I'm going to go upstairs and tend to the fires and make sure that we had 4.5 inches of snow on the ground when I went down there this morning. Ray says a mailbox outside of the Arizona place could house a sea star. Yeah, you sure could. I love sea stars for what they do, but the sea star is a small scope, and it can't deliver a view like this, unfortunately, because it doesn't have the resolution to see what this can see. But I love it. It's a great way for people to get into it. But I'll show you an example of one of the things that it may not be able to do. Like if we zoom in right here. Okay. Right here. You can see these subtle gradations in the color in here. And as we get a little more along, we'll start to see that there are some real fine filaments in this that show up. Let's do this. Let's go up here. Yeah. Like right here. See that? Fine detail in there. Ben's in front of his space heater in the attic. That's good. I'm in front of my space heater right here in my office. Wow, that's pretty. I think with your Celestron Next Star, you'll be able to see it, Ben. You'll be able to see some pretty cool things. I think that's the answer to the Sea Star, right? Yeah, this is looking pretty. We'll save it here at 24. And go a little longer. Let's go take a look at our sky, our all-sky camera. So we're getting, this is about the wall looking that way. So Orion's not yet near us. We'll see that in a short time. Not tonight, but another night. Reminder, on the 10th, the evening of the 10th, at midnight Eastern Time, I'll be on Coast to Coast with George Norrie, talking about interdimensional travel. It's something that a number of people and other astrophysicists have actually even come on board with, because they think that's pretty much the only way they can actually be here, an intelligent race from another place. It's the only sensible way for me. All right, so let's drop that down. All right, look at our beautiful flaming star nebula. This is hiding up in Auriga. Let's show you where that is. Okay, here's Auriga. And here you see it right there. And if we look at the mythology of Auriga, we can see that it's a goat herder. Okay. And inside there's some really cool things. And I never gave the flaming star a lot of credit because it was sort of boring to me. But then I started noticing all these complex loops and convolutions in it. And when I started to see that, I realized, holy cow, this is really a very exciting place. I couldn't believe I'd been giving it such short shrift, as they say. But I was. Here, let's, just for a moment, let's do this. Let me, hey, where'd I go? I'm missing. I'm not really gone. There I am. Yeah. Fine, I'm here. Yeah. Let's actually, let's get rid of this for a minute. There we are. Look at that. I mean, that's just a beautiful, look at this expansive, beautiful nebula. It's got blues in it. You know, here you see these blues here. These blues are reflection nebula, which are scattering blue light from the stars, hot star. This blue light here. And then this really cool feature of denser hydrogen that's overwhelming the dark material here, which is all mixed together, which is kind of the cool thing. This dark stuff and the hydrogen gas are mixed together. And the hydrogen's going to ionize as well. The dark stuff is going to scatter light and form blue perimeters on some of these things, like right here. Okay, beautiful blue right there. And that's what happens where it's really dense, where the hydrogen's really dense. You get these things, which are really cool. You know, and then up here, like that one there, right, and elsewhere. So that's actually a very cool and very interesting process that's happening up in this nebula. There's so much going on in this nebula. Look at that. That's just beautiful. I never realized how beautiful it was and how extensive it was, by the way. It goes out here. It's all out here. Look at this large loop here. There's a lot going on here. And as we zoom out, you can see that it continues. There's a lot more going on. This stuff continues down to the tadpoles that we were talking about. Okay, so we come back here. Let's go. Here is, let me go to the flaming star. Okay, so this stuff keeps on going down, right, and joins up with all of this stuff over here. And then we have the Spider and the Fly Nebula over here. This is a huge region of stuff over here. Then we have another large cluster over here. So next time we'll explore those other things as well. But it's really something in Auriga, you know, to see this. You know, or as Christopher Walken might say, Auriga, I think that's cool. You know? Hey, yeah. All right. All right, so now let's jump in here. See this here. Ben asked what's making the red color. I said it a few times today, Ben, but you were just popping in. That's okay. There's the most abundant element in the entire universe is hydrogen, and whenever you see red glow out there, it's hydrogen. What's happening is neutral hydrogen, where it's just a hydrogen atom where you have the nucleus, the proton, and an electron that's in the cloud around the nucleus. There's no glow there. That's neutral hydrogen. But if you have a star like this one that's hot and blue, or this one that's hot and blue, or this one, what happens is their ultraviolet radiation component can go out and hit the electrons in these hydrogen atoms. And as Sam S. just mentioned to you, it can then ionize those atoms. What's ionization? Ionization is where the electron leaves the atom for a period of time, leaving just a positively charged nucleus, because you only have a proton that's positively charged in the atom of hydrogen, and an electron, which is negatively charged. They balance each other, and there's no charge to the whole system. Leave the electron out, and now you have a +1 charge here. So electricity plays a fundamental role, and charge plays an incredibly fundamental role in the universe and how things appear to us. Okay, so when the electrons absorb energy and bounce off the atom like this and ionize, then you have the protons sitting around here. But then, inevitably, the electrons fall back into the atom. And when they do, they give off energy. And the way they give off energy is by light. And so the electron will jump down to a particular level in the hydrogen atom more than other levels. It can do that to other levels, but it jumps down to the level 2, called N as in November. N equals 2. Well, that N equals 2 level is the predominant one that the electron does when it comes back into the hydrogen atom, and that leaves us with a red glow. It gives off red light. Okay, so it's like 656 nanometer light, and so that's a red glow. We also call it hydrogen alpha. It's H2, which means a capital H with 2 Roman, number ones, HII, Roman numerals, capitals, and H2 is singly ionized hydrogen, because H1 is the ground state where you have hydrogen with its electron going around, and that's an H1 atom. But we just call it hydrogen. We leave off the 1 when we speak of it because it doesn't need to be stated. So that's what the red color is. It's the glowing hydrogen caused by the recombination of electrons with hydrogen gas. So pretty cool. All right, so let's bring this back in here. All right, and now let's bring back our telescope. Slide this over. There we go. And there's our telescope right here. All right, and let's move this up. This is beautiful. Now, if we zoom in on this now, we have 44 shots here. And now look. Now we actually have a lot of detail in here. What's that you say? You don't see enough detail? Okay, let me help you with that. Let's do this. Look at all the detail in here now. Looks like you're looking at a pillow that someone has ripped open of red soft cotton. That's really cool. So this is the black level. If I go past the peak, you'll see we're going to start eating away data. And if we get in here too far, you'll see that we lose all of our data. So we want to keep this just to the left of the peak amount of data. And there we go. And that gives us our beautiful flaming star nebula. Well, I hope you people out there and all my friends of ours and the SkyTour family out there, all of you, had a good time tonight. I appreciate that you came with us. It's a one-of-a-kind astronomy tour of the night sky. I'm proud to say that between myself and Marianne and Tara, who founded SkyTour, and with the assistance of Daryl, who joins us most nights, that we're giving you something rather unique. So hopefully you'd like to show us if you can. A one-time donation is great. SkyTourLive.org. We want to put the telescope in that Benson building, but it's going to cost us money. So anything you can would be helpful to us. And again, it's at SkyTourLive.org. When you go there, you'll see a donate button. Bam. Just go ahead, hit that, and you can tell it what you want. You don't have to give $50 or $100. You can give $1. You can give $2. Whatever you can to help us, because this is the stuff that we live for. And we love showing you this stuff, and we love teaching you all about this stuff. As winter comes, we're going to see a lot more things, and it'd be wonderful to have both telescopes being able to look at it in wide field and then close up. So that's something that we're looking forward to doing with you. All right. So anyway, I hope you guys have a good evening, and I look forward to seeing you again on the next SkyTour live stream. So you have a good night. And Richard, make sure that you send me. I'm hoping you already sent me a message. And Karen, use your binoculars. And look for more giveaways. We're going to be giving away more equipment upcoming, courtesy of our friends Tiffany and Mike, who are our power couple, power users of SkyTour live stream. All right, folks, have a good night, and we will talk to you on the next stream. So long, everybody. Woo-hoo. Good night.
Stars so bright in the sky, on Arizona nights they fly. Nebulae in colors rare, galaxies beyond compare. SkyTour in the night so clear, brings the universe near. Real-time wonders to see, streaming live for you and me. Lift your eyes to the skies, universe in all its light. SkyTour's bringing the views. Every night feels brand new. In the dark, the night unfolds, stories of the cosmos told. Through the lens, a distant dream, living real like a gleam. Far away, up so high, across the stars beyond the skull. Through the lens, a distant dream, living real like a gleam. Lift your eye up so high, across the stars beyond the sky. SkyTour shows us the way, every night a new display. Lift your eyes to the skies, universe in all its light. SkyTour's bringing the views. Every night feels brand new. Lift your eyes to the skies, universe in all its light. SkyTour's bringing